better than magic. These middle school students spent several class periods creating powered, mechanical flying machines from scratch. They've had to work carefully and trim off every gram of extra weight. There's nothing like it. They are releasing something they made with their own hands and watching it soar above their heads. Dreams of flying can come true. I've been experimenting for years, looking for an airplane design that would really fly. It had to be simple enough to build that my 6th grade technology students could make it as a first project in a few class periods. This is still a challenging project. You might have to do steps over again until you get it right. But in the end, everyone gets into the air, and many students' planes fly so high that they bump into the very high ceiling of our school's auditorium.
We're covered.
We've learned that there's no telling what's going to happen when we fly our planes. We expect the unexpected. And the hilarious. And the disastrous.
Whoa, I was looking through the monitor, all of a sudden. Oh, there it goes again. Yay! Oh.
It's all part of flying. This video presents step-by-step directions for making a model airplane that really flies. I'm going to ask you to do it my way the first time. That means following the directions closely and not doing anything that the directions don't say to do. Once you get a plane in the air, then you can experiment and innovate. The instructions are broken into steps. Some of the steps are long and some of them are short. I think it's important to watch a step through to the end of the step. If you don't see the whole step before working on your airplane, you might miss out on important details until it's too late. So how do you know when a step is finished? You'll see the video of the step reviewed in fast motion like this.
And you will hear me talking like this.
And of course, when the instructions are not clear, simply click on the playhead and drag it back a little to see that part again until it makes sense. And drag it back a little to see that part again until it makes sense. You're ready to start building the airplane. Go to part 2, propeller and fuselage. The propeller is the only ready-made part that we'll use. It's incredibly efficient. Blow on it a little bit and it'll turn. If you hold the propeller upside down and hold on to the round metal part like this, you can see how the propeller spins freely in one direction but catches in the other direction. That kind of mechanism that allows freewheeling in one direction but engagement in the other is called a ratchet. Perhaps you've seen a ratchet wrench, which can be set for one direction or another. If you look closely here, you can see how it works. The tip of the black propeller has sort of a ramp that either catches or slips on the metal part. We cut the rubber band from a giant 50-foot piece of rubber band. And you need to cut it to 12 inches unstretched.
Check out the propeller ratchet and cut 12 inches of rubber band.
The knot we use to make a loop in the rubber band is called an overhand knot. It's an easy knot, but it's more confusing because you put two ends together before you tie the overhand knot. You just sort of put the two ends together and pretend that they're one piece. Just make a loop and push the end through. Tighten the knot a little and notice that we have a problem. This loop is too small, and this end is just wasted rubber band, dead weight for the plane. You can solve both problems at once by moving the knot. You do it by grabbing and spreading the loop part of the rubber band. That way, you can actually move the knot toward the end and make the loop bigger. Move the knot until it's close to the end.
Tie the rubber band into a loop and move the knot toward the end.
A 12-inch long piece of balsa wood is the fuselage or body of the airplane. The smallest spacing on this ruler is 1/16 of an inch. 2/16 of an inch equals 1/8 of an inch. And the other way, it's 1, 2, 3/8 of an inch. 1/8 of an inch by 3/8 of an inch is a tight fit into the cup of the propeller. It can be difficult to get the end of the fuselage to fit in. But if you push the corners against the table a little bit, it's much easier to get it in. If you have trouble getting it all the way on, push it against the table, but let the propeller hang out over the edge so it doesn't get bent in the process. But don't hold it far away, or when you hook the rubber band to the propeller, the knot is always away from the propeller. If you look closely, there is a space where you can slip the rubber band in. If you don't mind holding the other end, you can wind it up now.
Attach the propeller to the fuselage and hook up the rubber band.
There are lots of ways to hold the other end of the rubber band. Using a piece of a small paper clip works well. Don't use a large paper clip. It's too heavy and it's hard to bend. Straighten the paper clip enough to get a 1-inch piece from it. Mark it at 1 inch and cut it with a pair of pliers. Look at the pliers to see where the cutting part is. Once you have a piece cut off, bend one end around so it's not sharp. You decide where to put the rubber band holder by how much the rubber band stretches. If the rubber band is stretched like this, there will be too much friction in the propeller and it probably will not fly. At the other extreme, if it's loose like this, it'll take forever to wind up. So the rubber band should be straight but not stretched. Hook the sharp part of the paper clip into the rubber band loop and poke to mark the fuselage where it will go in. Then lay the fuselage on a table to back it up and push the paper clip all the way through. Notice that it came out the side, and that's okay. Just patch it up with some hot glue to make it stronger. There is a trick to getting strong connections with hot glue. If you just lay a blob of hot glue on a piece of wood, it'll sort of stick. But with your fingernail, you can just knock it right off, and no trace remains. But if you can smush and push the glue into the wood fibers when it's still soft, the glue gets a good grip on the wood. Here, the best I can do is try to slice off the glue with my fingernail. But even then, there's some glue that I cannot get off. It's grabbing too hard onto the wood fibers. So glue the rubber band hook into the fuselage and push the glue into the wood fibers. Let the glue cool and harden for a minute, and then consider which way to bend it. If you bend it toward the propeller, do you see what will happen? That's right. When there's tension in the rubber band, it'll slip right off. So we bend it away from the propeller to hold it on. But look what happens when I put some tension on this rubber band. It looks like it might pull out. Use your best judgment to decide how much glue, if any, you need to strengthen that hook so it doesn't come out.